Hello everyone. In this lecture, we will discuss the concept of graph from exam point of view, right? Now, initially, when we start about this topic, we should know the basics of graph. We know that graph is a non-linear data structure. If I talk about linear and non-linear data structure, we know that in linear data structures, we have array, we have stack, queue, and linked list. And in non-linear data structures, we have tree and graph. So graph is a non-linear data structure. And if you remember in class also, I have discussed that what are the different examples, real life examples of graph. If I discuss the brain structure, right, we have a lot of neurons, millions of neurons in our brain, and they are connected, right? So there is a connection between one neuron to another neuron in the form of some information. Means in terms of biology, there will be some chemical information that will be getting transferred from one neuron to another. But the thing is, overall, if I talk about this brain structure, this neurons are denoted as nodes, and the connection between two neurons is represented as edge, right? Similarly, if I talk about your social media networks, whether it is Facebook, Instagram, or any other platform, there we people who have our account are called as nodes, and the relationship between two people, let's say A and B, are two particular accounts on a social media handle, right? Instagram. And if there is a relationship between them, then it means they will be friends to each other, means either they will be following each other, or if I talk about Facebook also, A and B are connected if they are friends, right? And they are not connected if they are not friends. So in this way, actually, we will try to understand the concept of graph, and then after understanding the algorithm, these algorithms are also applied on the real life examples also. Now, what is a graph? These are the example, but what is the graph? Graph is a collection of vertices and edges. Your vertices are also called as nodes, and in short, we represent the vertices and nodes with capital V and the edges with capital E. And this nodes will represent a person, a thing, or any entity. Okay. And it can be like it can be representing a human who is having some account, or it can be representing any other means. Let's say if I talk about different cities of a state, or different countries of the world, or different continents of the world, they can also be represented as nodes. And if I talk about E, that is edges, it is the relationship between those nodes. So nodes can be anything, and the relationship between those nodes can be E, edges. So in short, I can represent G, which means graph is a collection of set of vertices and edges, V comma E. Fine. Now, so if it will be asking you what is graph in your exam, simply you need to explain that it is a nonlinear data structure, which is a collection of vertices and edges represented like this. And here you have to represent that V is nodes and E is relationship between the nodes. And the real life example of graph is neurons and social networks. Now let's move to the next. So here we are going to study a few concepts related to a graph. So let's say if I represent a graph like this is your graph, right? Here I have four nodes. So I can represent it like this. Here I have not labeled the graph. I am simply telling this is the structure of a graph. This red dots that I have put here, red circles, they are called as nodes or vertices. And this blue edge, this blue line between the two nodes is called as edge, which is basically the relationship between the two nodes. Now let's take a graph which is labeled. Now in this example, this is also a graph. We have how many nodes here? A, B, C, and D. Four nodes are there. And how many edges are there? There is one edge between AB, then BC, then CD, and DA, and also BD. So we have five edges here, right? So I can say that G is a graph having V and E, vertices and edges, where the number of where the vertices set is A, B, C, D, and the edge set is, as I have already discussed, there are five edges. So you clearly mention it, right? And another concept is degree. So degree is the edges, the number of edges incident on the node. So if I talk about A, there are two edges, means, or you can say there are two edges which are connected to this node. So degree of A, D means degree, and A is the node. So degree of A is 2. Now if I talk about the degree of B, it is connected with 3 edges. So degree of B is 3. Similarly, degree of C is 2 and degree of D is 3. So I have written the degrees here. Now if I talk about this graph, this is a undirected graph because there is no direction from one node to another node. So I can go from A to B as well as I can come from B to A also. So this is unique undirected graph. There is no direction involved. But if let's say if this kind of structure is there, that this arrow is there between on the edge, if there is an arrow on the edge, this shows that there is a path from A to B, right? But there is no path from B to A. You can go from A to B, but you cannot go from B to A. This is directed graph. But in an undirected graph, you can go from A to B as well as from B to A. So this is how a directed graph will look like. So we can travel from here to here, then here to here, and this way, but we cannot go from here to here. So this is the concept of directions. Okay, so let's say here I have given one example. I have also taken one more graph. You can say there are how many nodes here? There 5 nodes are there, A, B, C, D. I've just given an example for you to write. Now you can write the edges also. How many edges are there in this case? We have 9 edges, and similarly the degree of every node. So A is having degree 4, E is having 3 degrees. Similarly, you can write others also. Okay. Now we have studied what is a graph, what are the applications of graph, and what are the type, how to represent a graph, right? Uh, Mathematically. But now we will understand how to represent a graph in your computer basically. So there are two ways. This is very, very important for your exam. So if I talk about your graph, this one way is adjacency matrix, another way is adjacency list. Fine. Now here what we are trying to do, let's say I'm taking this particular graph. Here this graph is having 4 nodes, A, B, C, D, and there are 5 edges. From we have edge A, B, B, C, C, D, D, A, and B, D. 5 edges are there. Okay, so we can also write the degrees of A, B, C, D here. Now the number of nodes, n is basically the number of nodes or the number of vertices. Here are 4. Fine. So in adjacency matrix, you know 2D matrix. What is matrix? We have studied it in mathematics that it is a 2D array, right? So n is 4. So we will be creating an array of 4 into 4 size. So if the number of nodes are n, then a matrix of n cross n will be created. So n is 4. So see, you can see 4 rows are there and 4 columns are there. A, B, C, D. Similarly, you will write A, B, C, D over here. Fine. And what we are going to do, from we have to see whether there is an edge between, if there is an edge between 2 nodes, I will write it as 1. If there is no edge, we will write it as 0. So as you can see, as I have already told you, in a graph, in a simple graph, like whatever we are going to study in this module, we are always going to refer a simple graph. In simple graphs, we don't have the concept of self loop and multiple edges. What are self loop? If there is a node from B to B itself, but there is no edge like this, there is an edge from B to B, then that is a self loop. And similarly here you can see from B to C we have one edge. Between 2 nodes there is only one edge in this graph, but if there is more than one edge between 2 nodes, that is called as multiple edge. But these two concepts are not involved in your simple graph, and in this whole module we are going to refer only simple graphs. So it is saying that, do we have a no edge between A to A? No, there is no edge, there is no self loop on A. So A to A, the distance is 0. Now A to B, do we have any relationship between A to B? Yes, there is a relationship. There is an edge from A to B. That's why I'm going to write here 1. A to C, there is no edge, so it is 0. A to D, there is an edge, so it is 1. So this is the row of A. Now coming to B. B is connected to A, D, and C. So B is connected to A, there is an edge 1. B is not connected to B, so it is 0. B is connected to C, there is an edge from B to C, yes, so 1. There is an edge from B to D, yes, it is 1. Similarly, I'm going to write it for C. C is connected to B and D, so you can see B and D are 1, and rest of them are 0. Similarly, D is connected to everyone except D because there is no self loop. So D is connected to A, B, and C. This is 0. Now there is one important concept here is, if you see this diagonal, you can see all that the diagonal elements are always 0. So in one property of your adjacency matrix is, the diagonal of your adjacency matrix is 0, right? And the second important concept involved here is, if I count the number of rows of a particular number of ones of a particular row in the adjacency matrix. See, count the number of ones, 1 1, there are number of ones are 2, and this is actually the degree of this particular node. And we have calculated here also that the degree of A is 2, but if you count here the number of ones, it is 2 only. Similarly, if I count the number of B's, number of ones in this row, it is 3, so degree of B is 3. So basically you have written it yourself here, but this is also a representation. So in this way, from the adjacency matrix, we can get to know that what is the degree of a node, and also we can get to know that if there is a edge between particular two nodes or not. So this is very very helpful, right? So this is one way of representing your graph. Another way is called as adjacency list, where we use the concept of linked list. So in adjacency matrix, we will be using the concept of array, and in adjacency list we will be using the concept of linked list. Fine. Now how it is represented? In case of your memory, I'm just writing all the nodes A, B, C, D, and whatever means adjacent nodes are connected to that A, that particular node will be represented in the form of linked list. So A is connected to B and D, so I am creating a node, and I am storing the address of B in next part of A. Similarly, the next part of B will store the address of the other node D, and this is not storing any address, so it will be null. Similarly, the neighbors of B are, we know that the neighbors of B are A, C, D. So you can store it in any order in linked list, there is no issue. So B's next part will store address of A, A's next part will store the address of C, and C's next part will store the address of D, and the last will be null. Similarly, you can store the information of C and D. So this is how we represent it in linked list. So one more important thing here that I want to tell you is, you know the concept of a graph. If your graph is fully connected, means, see, there is one edge which is not connected here. So if this would have been connected, then this graph would have been a complete graph, right? So if your graph is dense, means there are a lot of maximum number of edges which are connected, or you can say in the adjacency matrix, if there are more than one, there are more than ones than zeros, in that case you can say that your graph is dense graph. So for dense graph, we will always use adjacency matrix. And if a graph is sparse, means there are more number of zeros, so it means there are less number of edges, in that case we will refer this adjacency list concept. So you should also know where my adjacency matrix is used and where adjacency list is used. So if this question comes in your exam, you have to represent these two, means you have to explain these two methods, as well as you will take one example and you will explain how this particular graph can be represented by both the methods. And also you will tell the properties of your adjacency matrix that I have discussed, that the diagonal matrix is 0, and the degree of a particular node can be calculated by the number of ones in a given row. Fine. And you will also discuss the applications of adjacency matrix and adjacency list that I have discussed just now. Now the next concept is this thing that I have discussed with you. So here you can see that in this particular graph, let's take an example here. We have, you can take any example. So I have taken one more example. N, his number of vertices here are 5, and the number of edges are 8. So you can see that in this particular adjacency matrix representation, there will be more number of zeros. So this is, it means this is a sparse graph. So for sparse graph, we will refer adjacency list, and if this would have been fully connected, in that case we would have referred adjacency matrix. So another thing, another concept is we have discussed in the tree module that the ways of traversing a tree are in order, pre-order, and post-order. But the methods of traversing a graph are DFS and BFS. So for DFS means depth first search, and BFS means breadth first search. And for DFS, the data structure that we will use is stack, and for BFS, the data structure used is queue. So we will discuss this in detail. So now let's discuss BFS. So in BFS, what we are going to do, we are given a graph and we have to traverse all the nodes of the graph, right? Be very careful about the traversal techniques. In tree traversal, it is in order, pre order, and post order. In graph, it is BFS and DFS. So I have just now told you the full form of BFS and the data structure used in BFS, and this is your given graph. And let's find out this. So in the question, it is given that I have put an arrow and indicating that this is your source node. Source node is the node from where we are going to start the traversal. So I have written one, means I have to traverse this node first. So first I have traversed the node 1, and now what I have to do in BFS, I have to first of all write the neighbors of 1. What are the neighbors of 1? 2 and 3. So this I have highlighted, this means the neighbor of 1 are 2 and 3. Now what I'll do is I have put the neighbors, I have taken 1 and I have written the neighbors of 1. I can write it in any order. I have written 2 3, or you can also write 3 2. So that is why more than one BFS order or DFS order is possible. So don't get nervous if you get a different answer. So there are more than one possibilities for BFS order. So I have here taken 2 3. So 1 2 3. Now the next node is 2. So we are going to write the neighbors of 2 after this. So I have picked 2, and the neighbors of 2 are 4 and 5. So I have written that, this highlight I have highlighted with yellow color, that 4 and 5 are what? These are the neighbors of 2. So similarly, you can write it any order. You can write 4 comma 5, or you can write 5 comma 4. So again, there will be different orders possible. So then I'll pick the third node, and after these nodes we will write the neighbors of 3. So neighbors of 3 are 6 7. So you can see with blue color I have highlighted this, the neighbors of 3 are 6 and 7, and you can also write it 7 comma 8. It is your choice, as I've already told you. So there are a lot of BFS orders possible. Then I will pick 4. When I'm picking 4, you can see the neighbor of 4 is what? 8. So I've written 8 here. Now I'll pick 5 and see if any particular neighbor is visited. So neighbor of 5 is 2 and 8, which is already visited. Neighbor of 6 is already there. 3 and 8 is already traversed. Neighbor of 7, that is 3 and 8, is also traversed. So we can say that all the nodes have been traversed. So this is BFS order. You be careful that you have to first of all traverse the neighbors. Means first of all, when you visit a node, you have to after that write the neighbors of that node. Now let's take one more example here. So here I have taken a queue and I have explained how this actually works, but for now we are just focusing on writing the order. Maybe in the next video I'll tell you the explanation also. So here we are given a graph where I am supposed to write the BFS order. So as I have told you, here they have given in the question that try to write it in alphabetical order. So A obviously we have to pick, because this is your source node. So I have taken A. Now B and S both are the neighbors of A, but you have to write it in alphabetical order. So first of all you will take B and then S. Now you have to see whether any neighbor of B is unvisited or not. No, because only A was connected to it. So A is already there. Now I'll go to the next neighbor, that is S. What are the neighbors of S? C and G. Write it in alphabetical order. So I'm writing C and G. First I'm writing C and then I'm writing G. After that, what you need to write? Uh, you have written the neighbors of S, then you will write C and G, and now you will pick the next node, that is C, and the neighbors of C are D, E, and F. Again, you will write it in alphabetical order. So I have written D, E, F. So after C has been traversed, we will go to G and see what are the neighbors of G. Neighbors of G are F and H, C and S. C and S are already visited. F is also visited. H was not visited. So I have written H here. Now I'll go to the next node, D. The neighbor of D was C, which is already visited. Then we will go to the next node, that is E. Neighbor of E are C and H, which are already visited. And then we have F. Neighbor of F is also there, and neighbor of H is also there. So in this way we can say that all the nodes have been visited. So we have done two examples and you have understood how to write the BFS order. Now this is one example of BFS. Here you take source node as A and write the BFS order in the comment box. So it is a practice question for you. Similarly, I have taken one more example here. If you want to write the BFS for this, let's say the source node is E. So first of all, I'm going to write E, and after that you have to write the Neighbors of E are BCG. So I have written BCG, right? Now E have been visited. Now go to the next node B. And what are the neighbors of B? E and A. So E is already there, but A was not there. So I have written A here. So now B is also done. Now we'll pick C. And the neighbors of C are E, A, D. E and A are already there. Now we will write D also. So I have written D. Then we'll go to the next node, that is G. Neighbors of G are E and D, which are already there. After that, I am going to write the neighbor of the next node, that is A. So neighbor of A is B and F. B was already there. Now I'm going to write F. Then I'll pick the next node, that is D. The neighbor of D is already there in the order, this traversal. Then I will pick F and the write the neighbors of F. A and H. A is already there and I have written H. And similarly in the last I'll visit H also. In this way, all the nodes have been visited by BFS. So this was about BFS order. Okay. DFS is very, very easy. So we will discuss DFS maybe here or in the next video. So see, if you wanted to write the DFS for this, DFS is very, very easy. This is BFS, but I'll take another example where I'll discuss DFS with you. But if you are clear with BFS, because BFS is more difficult as compared to your DFS, right? Trees, which is very important. Just hold a second. We are given a graph here, as you can see. This is your graph, right? A, B, C, D. This is your graph. Here we have a cycle. Your graph is having n is equal to 4. 4 nodes are there, and vertex are A, B, C, D, and edges are A, B, B, C, C, D, and D, right? So to construct the minimum spanning tree, there are two conditions that you need to take care, that in the minimum spanning tree there should not be any cycle, and secondly, not minimum spanning tree, just discussing the spanning tree. First thing is the number of, there should not be any cycle in the given graph spanning tree, and then the number of edges in the spanning tree should be n minus 1. So here the number of nodes are 4, but the number of edges in the spanning tree will be n minus 1, that is 4 minus 1 is equal to 3. So this is your graph. What are the possible spanning trees? The possible spanning trees are 4. Let's see how. As I have told you, there will be no cycle here, and the number of edges will be 3. So from this, you have to make a resultant graph which is having only 3 edges, and there should be no cycle. So I have not connected. So I have removed this edge. And now you can see this is having 3 edges. So number of edges are 3 and it is not having a cycle. Similarly, next time I have removed this edge, you can see there are 3 edges and there is no cycle. Again, here I have removed this edge. Now we have 3 edges and there is no cycle. Similarly, here I have removed this edge and the number of edges here are 3, so there is no cycle. So these are the number of spanning trees. So number of spanning trees in this particular case is 4, but if we need to find out the minimum spanning tree, that concept also we will study. Basically this topic comes under minimum spanning tree concept only, but till now what we have discussed is spanning tree concept. Okay, this is your graph and this is the spanning trees possible for the graph, and this is the condition of your spanning tree. What is that? There should be no cycle and the number of edges should be always equal to n minus 1. So here 4 nodes were there, but edges in the resultant graph will be 3. So let's say if I discuss about this, n is equal to 5. If you want, so this is a cyclic graph of node 5, node 6 and node 4. If you want to make the number of spanning trees in a cyclic graph, that will be always equal to n. Like if I discuss the previous case, this is a cyclic graph only. This is a cyclic graph. And how many spanning trees were possible in this case? 4. Because every time you can remove any of the edge. So similarly in here also, how 5 spanning trees will be there? Because in first case I will remove this edge, then I will remove this edge, then I will remove this edge and this edge. So 5 possibilities are there. So 5 graphs will be possible, spanning tree graphs. And similarly here also 6 spanning trees will be possible, and here 4 spanning trees will be possible. So this thing you should be knowing, right? Now let's take a complete graph. So here we have a complete graph, and we have n is equal to 4 and edges is equal to 6. So we have 4 nodes and all the nodes are connected to each other. So here also, first of all, you should know how many spanning trees will be possible. So this we have already done. Now there can be possibility that these edges are connected, right? As I've told you, n is equal to 4. The number of edges in the spanning tree will be 3 and there will be no cycle. So these are 4 spanning trees of a particular shape. Now here also you can see these are next 4 possibilities of your spanning tree and there is no cycle in them. Similarly, these are another 4 possibilities, and these are also one more 4 possibilities. Total 16 possibilities are there. So number of spanning trees in this case will be 16. Now be careful that I have written this. People may think that this is cycle. This is not a cycle because here we don't have a node. This is not a node. If we will open it, it will be something like this. Okay, but the structure is like this, so you should be knowing this, right? In this case, this structure is different from this because here this node is connected to this, but here this node is connected to this node, so they are different in structure basically. So be careful about this also. This is very important for your exam also. So in the same question, what I have done now, now I'll find out the concept of minimum spanning tree. We will understand the concept of minimum spanning tree. Till now we have studied only spanning tree. So with when the minimum spanning tree concept will arise, there will be some weight associated with your edge. So all the nodes should be covered basically. When you are making the minimum spanning tree, all the nodes should be covered, and there should be no cycle in the resultant graph, and the number of edges should be n minus 1. So as you can see in for this question, I have made 4 possible spanning trees, and I have also associated weights with that 1, 2, 3, 4. So 4 weights have been associated. So if you want to find out the minimum spanning tree, you know that if you will pick A, B, B, C, and C, D because they have minimum weights, this particular the graph minimum sorry the spanning tree which will be including 1, 2, and 3 will be your minimum spanning tree. So you can see 1, 2, 3. So this particular graph, if you add the weights, it is 6. Similarly, if you add these, it will be 8, this will be 7, and this will be 9. So out of all the 4 spanning trees, this is minimum because the weight is minimum, right? And you can write the weight also. So this is something that you can calculate yourself. But if we have graphs where the number of nodes are very large, in that case applying this rule will not be beneficial because manually looking into the number of nodes and their edges and their weights will be a tedious job, and it cannot be performed manually. So you have to do it through some algorithm. So for minimum spanning trees, there are 2 algorithms which are used to actually find out the minimum spanning tree. So we will understand that in the coming slides. The first algorithm that we have is Kruskal algorithm, and the second algorithm is Prince algorithm. Let's study them one by one. Okay, now we have discussed the concept of spanning tree, and we have understood how to find out the total number of spanning trees. Then we also discussed the concept of minimum spanning tree. But manually calculating the edges which are having the minimum weight is not possible when the number of nodes are very very large. So for real life application, we should have some algorithm, and the algorithm is, we have 2 algorithms, Prince algorithm and Kruskal algorithm. Kruskal algorithm is easy as compared to your Prince algorithm. Now let's understand the working of Kruskal algorithm. In this case, you have some nodes given and the weights associated with the edges also. So what you have to do is you have to simply write all the edges in ascending order. So I have written AB, that is of weight 10. Then I have written DF of weight 12. Similarly, DG of weight 14. And in this way, you will write all the edges in ascending order, right? Then after that, you will write, you will means take all the nodes, okay, and you will connect them one by one. So you will select the first edge, that is 10. So you will connect the 10. A and B, you will connect A and B. So and you will put a tick here saying that it is visited, or you can in computer it will be written as visited. Then we will take next smallest edge, that is 12, and I will connect 12. After that, we will take the next one, that is 14. So I have connected 14. Then we have GD, that is 18. So 18 is there, but we cannot connect it because if I connect this edge, then it will form a triangle, which is a cycle. So this is not possible. So that is why I have put a cross, that it means stating that this edge cannot be connected because they will form a cycle. So I have not included 18. Then moving to the next smallest edge, that is 22. So I have connected 22. Then CG is there, that is 24. So CG is there 24. If I connect this edge, then you can see that it will form a cycle. So that is why it is also not connected, it is not taken, right? Then we will take the next edge, that is BC 25. So I have connected this edge. And then we have a next minimum edge, that is 28. So 28 is there, but we cannot connect it. If we connect it, then it will form a cycle. So the condition of your spanning tree is there should not be cycle. So these are the three edges which will not be connected. So in sometimes in exam, they may also give you a graph and they may ask you what are the edges which will not be connected in the resultant spanning tree. So your answer will be GD, CG and AF because they are forming cycle. Now here if I take, see how many nodes are there, A, B, C, D, 3 and 3, 6 nodes are there. So if in your original graph there are 6 nodes, though in the resultant graph there will be how many edges? N minus 1, that is 5. And you can see that there is 1, 2, 3, 4 and 5. 5 edges are there. 6 nodes in the original tree, but 5 edges in the resultant spanning tree. And this is minimum spanning tree. After applying the Kruskal algorithm, you have to calculate the weights, total weights, sum of the total weights. So just sum them, and the sum is 86. 1 marks will be deducted in the exam if you write the incorrect weight. Sometimes what student do is they take one or the other edge which is incorrect and should not be the part of your spanning tree. बाकी उनका पूरा ट्री सही होता है, बट एक एज वो गलत ले लेते हैं जिसकी वजह से उनका ये वेट जो है वो गलत आता है. तो उसमें आपके 1 या 2 नंबर कट सकते हैं अगर आपका ज्यादा नंबर का क्वेश्चन है तो बी केयरफुल अबाउट दिस ऑल्सो. Now let's understand Prim's algorithm. In Prim's algorithm, the same question I have taken, and see, for both Prim's and Kruskal you have the same structure. जैसा structure आपने Kruskal का बनाया था जो resultant graph है आप देख सकते हो, बिल्कुल वैसा ही आपका structure बनेगा. किसका? आपका बनेगा इसका Prim's algorithm apply करने के बाद भी आपका same spanning tree बनेगा. So now here in Prim's algorithm, what we have to do is we have to pick any of the nodes, and we will find out the adjacent edges from it. So let's say I have picked here F. You can pick any of them. So you can pick anyone. Let's say if I have picked A or F, anything you can choose. Let's say in this example I am picking A. So from A there are two edges going on, means two edges coming out of it. So I'll pick the smaller one. I have picked 10. Now B is included in your set, and from B you can see one more edge is coming, that is 25. So now in our set we are having three edges, 10, 28 and 25. 10 is already there, so we cannot it is already there, so we will focus out of 25 and 28, we will find out which is smaller. So we know that 25 is smaller, so I have connected 25, right? After that, C is also included in our set, and from C there are two more edges which are coming, that is 24 and 22. So out of 24, 22 and 28 we have to find out which is minimum. 22 is minimum, so I have connected 22. Now D is also included in the set, so two edges also coming out of it will be included, that is 18 and 12. So out of 24, 28, 18 and 12, which is minimum? 12 is minimum, so I have connected this. Now E also will come into the set, and then edge coming out of it is 16. So I have to also include 16, right? So now what will happen? We will have we will connect the minimum edge out of the remaining edges. 16 will be connected. After that, F is also there in the set, so we have 28 and 14 edge connected to us also, and we have 24, and similarly we have 18 also, but which is minimum? 14 is minimum, so I have connected this edge. Now coming to the remaining edges, if I take 24, I cannot connect because it will form cycle. I cannot connect 18 because it will form cycle. I cannot connect 28 because it will form cycle. So this is the resultant spanning tree, and if you will add the edges, the same result will be formed, and the result will be 86. So both Prim's and Kruskal are used to find out the minimum spanning tree. If the weights are unique, in that case the graph will be the minimum spanning tree graph from both the algorithms will be same. And if the weights are same, there are duplicate edges are available, in that case there can be more than one structure, but the result will always be same. So this is one more example. You have to make means you have to apply Kruskal and Prince algorithm on this graph, and you have to find out the result. Okay, we have discussed this. Now, if I apply Prince and Kruskal, this the explanation is given very well. First of all, you will take the minimum edge. I have taken one. Then next minimum, that is two. Then the next minimum, that is three. Then the next minimum is four, and then five. They are connected, but we cannot connect this five because it will form cycle. I cannot connect six because it will form cycle, and I cannot even connect six because this will form five cycle. So the total sum is 15. If I apply Prince algorithm, I can, as I have already told you, I can choose any of the nodes. So if I choose, let's say this node, so from this node, three edges are going, 5, 5 and 2, which is minimum 2. I have connected 2. Now with this addition of this node, 4 and 6 are also there in our set, so I will connect the minimum, that is 4. From this, there is more edges added, that is 1, 5 and 6 are also added, which is minimum, 1 is minimum, so I have taken 1. Then when this is connected, this will be also now having new edges, that is 6. So we have 6, 5, 6, and then we have 6, the remaining are there, right? ये सब हमारे पास edges बचे हुए, 3 नहीं है but अभी हमारे पास. So I'll connect this, minimum out of them is 5. So I cannot connect this 5 because it will form cycle. So I have taken this 5. So it will be there in the set. After I include this edge, this node will be available. And from this node, I can see 3 is also there, which is minimum. So I'll take 3. And similarly, I cannot connect these edges because the dotted ones, we cannot connect because it will form cycle. So you can see that both of them are giving you the same result, and the structure is also same. Now this is a practice question for all of you. You have to make the you have to apply Prim's algorithm as well as the Kruskal algorithm, and you have to find out the minimum spanning tree out of it, and you also have to write the minimum spanning tree cost. You can put the answers in the minimum. You can put the answers in the comment box. I'll check and verify whether it is correct or not. So that was about a brief introduction about graph. So better you first of all complete this. Now next topic that we will do will be tree. So that's all for today. Thank you so much.